Today we're going to talk about 10.6 and 10.7, which is locus. And locus is a figure that is the set of all points, and only those points that satisfy one or more conditions. So I'm going to give you an example. Like I'm going to say the set of all points, or the set of all students in Mrs. Marnell's honors geometry class. And that would be all the locus of points, or the locus would be all of these students in the geometry class. Typically, what I want you guys to give me as your answer is a sentence explaining, and then you're also going to try and give me a picture as part of your answer. And quite honestly, it's easiest for you guys to see what locus is if I show you guys an example. So, describe the locus of points in a plane satisfying the given conditions. The locus of points, basically, if you don't like the word locus, you could think about it as the set of points 10 centimeters from a point. Now, there's two different ways to think about this, and I think the book is a little bit more specific than I was in this question because I want to talk about both possibilities. You could talk about the set of points in a plane versus the set of points in space. A plane, two-dimensional, space, three-dimensional. So the set of points 10 centimeters from a point. So there's my point. What are all the points that are 10 centimeters? That's going to be a circle. That's going to be a circle with radius of 10 centimeters. So that's in a plane, drawing it on my board. Versus space, think three-dimensionally. So not just moving up and down, left and right, moving front and back. So in space, what you're going to have is you're actually going to have a sphere. Where that radius of that sphere is 10 centimeters. So this would be a sphere with radius of 10 centimeters. Okay, the next one. The locus of the center of a circle with radius 5 centimeters as it revolves about a circle A that has a radius of 2 centimeters and to which it is externally tangent. Now that's a little confusing and I think even a little awkward. So what you have to do is you have to break down that question. Okay, the locus of the center of a circle with radius 5 centimeters. So let's talk about a circle whose radius is 5 centimeters. Okay, so that's our circle. As it revolves about a circle A that has a radius of 2 centimeters, so A is going to have a radius of 2 centimeters, and to which it is externally tangent. I'm assuming it, and that's a little vague, and I would try and be more specific on the test. I just stole these questions from the book. It, meaning this circle and circle A are externally tangent. So externally tangent, let's make that look a little bit more like a circle. They are externally tangent. One point of tangency, circle A, that has a radius of 2 centimeters. So now let's look and see what's revolving. The center of a circle with radius 5 centimeters. So what's happening here? So the locus of the center of a circle. So this center, as I revolve, think of, I'm going to revolve this point around. The other circle. Think of me rolling, and I wish I could show it to you guys. I'm rolling that red circle around the other circle. Well, what's my locus of points that I drew in green? That's going to be a circle with radius of, well, what's that whole radius? That whole radius is 5 plus 2, 7 centimeters, with the center at A. And I guess we're assuming that this is in space, or I'm sorry, in the plane. And the book is a little bit more specific than I was. All right, our last example. The locus of all points equidistant from the vertices of a triangle. And again, let's assume this is in a plane. So just thinking about my smartboard. So, vertices of a triangle. Okay, now this is where locus get very challenging, because we kind of expect you guys to use all of your knowledge of everything we've talked about in geometry. So locus of all points, so basically the set of all points, equidistant from all three vertices. So what point is equidistant from that vertice, and that vertice? I may not have drawn it particularly the best, but if you remember way back in one of our sections this chapter, I talked about the point that's equidistant from all three that allowed us to circumscribe a circle about that, and that's a circle, I promise. Look at that beautiful circle. About that triangle. What was that point? Well, that point, or what point, is equidistant from two endpoints of a segment. Each one of these points is going to be on the perpendicular bisector. So point is on the perpendicular bisector, or I should say the point is, or the locus of points is the intersection of the perpendicular bisectors of the three sides. Now, how do you get extra bonus points and make it Mrs. Marnell very, very happy? You say that this point is called the circumcenter. Okay? So again, locus, it's using all of your knowledge of geometry. It's just going to take you guys a lot of examples to get used to what the idea of locus is. There are your 2 lesson questions. All you have to do is explain in a sentence. It's going to be hard for you guys to draw me a picture on the Google form. So just explain in a sentence each one of those locus of points.